right, so today we're talking about energy and heat and like how heat is transferred between objects. But I guess first we got to talk about conservation of energy because we're going to talk about like how energy changes forms, but really the total energy stays the same. Do you
Okay.
remember what the law of conservation of energy is?
I think it was like the law of conservation of mass, right? Pretty much you can't
Mhm.
create or destroy it.
Right, yeah, that's right. If I cut an apple in half and I just have, the two halves of an apple, has any matter really been lost?
No.
No. So if I, am burning something, is any energy really lost? Can energy ever really disappear?
Hmm. I don't think it can be destroyed, but it's changing forms.
Yeah, yeah, there you go. So that's a good thing to remember is that total energy, the total amount of energy in the whole universe stays the same, right? So we're going to write down the law of conservation of energy so we can remember it. The total amount of energy in a system, let's call it a system, stays constant. Energy cannot be created or destroyed. That last part is really, really important. The energy cannot be created or destroyed. It only changes form. Okay, and we're going to talk about how energy changes form in this lesson. If we could divide up all energy in the whole universe into like two main categories, what do you think that those would be?
Um, well, I think energy has to do with movement, right?
There is some energy that has to do with movement, yeah.
What's that called? Movement
That is called kinetic energy. Kinetic energy. That's the energy of movement. So kinetic is one of them.
energy. And then I think the other type of energy would be maybe the possibility to have some sort of movement or the possibility to influence other things.
Right. So if you're sitting right here, do you have the possibility of doing other things, of influencing other objects,
I
right?
do. I'm not currently influencing anything, but I could.
You could. Like you could get up and move around and all that
Yeah.
stuff. So you have energy like stored up inside of you that
Mhm.
you could use. You have the potential to do other things,
Mhm.
right? So that's what we're going to call the second category. The second category would be potential energy.
Kind of like a sandwich. I ate a sandwich for lunch, and that is going to give me the potential energy for me to go do something later.
That's right, yeah. To, go ride a bike or play frisbee
Mhm.
or something like that,
And
right?
that's changing that potential into kinetic, getting that movement.
That's exactly
Yeah.
right. So let's write down the definitions of those just so we can remember how they're different. Kinetic is energy of movement. So then potential energy would have to be the energy of position, depending on like where you are. You have energy stored up inside of you that could be used for other things. So potential is energy of position. Oh, it's not very, there we go. So where do you think, since we're in chemistry,
Mhm.
where do you think that chemical energy would fall between those two categories?
Chemical energy. Hmm. I would say probably in kinetic, right? Because I mean, things have to be moving in order for that energy to be unleashed.
What things would be moving in a chemical reaction?
Um. Well, from what I know from different combinations, I would say the electrons would have to be moving around.
Yeah, that's right. Whenever things combine with each other, those little tiny, tiny particles are moving around and making other things, right? So
Mhm.
that's perfect. So chemical, let's remember that. Chemical energy and heat, because we're going to talk about heat here too. Chemical energy and heat are kinetic. right? And we're going to think particle movement. That's perfect. In chemical reactions and when something like, you know, the temperature changes and something, those particles are moving around. So that's why they fall under kinetic energy between those two types. All right, and we got to remember that when energy is transformed, right, when it changes forms, no matter what, the total energy remains constant. The total energy in a chemical reaction doesn't change. So we're going to remember that too. Total energy remains constant. So let's talk about heat then. Heat is what we call thermal energy. So thermal, like thermometer, it measures heat, right? So thermal energy is heat energy, and it's the energy that flows. It flows between objects. Have you ever been like really cold at a sports event and you put those hand warmers like inside your gloves? You know, I used to do that whenever I played soccer, right? So how are those gloves warming your hands?
So I think it's a chemical reaction happening in those little packs. And then that heat comes from the outside of our skin. We kind of take in that heat, and then it kind of spreads throughout our body, through our blood. Yeah,
that's right, and that's how it gets you warm, right? Heat would flow into you from those hand warmers, right? So heat is energy. Heat is energy that is transferred. An object doesn't have heat, okay, technically. Heat is energy that's constantly moving, and it flows from warm objects to cold objects. So
just like the same water molecule can have a lot of thermal energy and be a gas and be bouncing all around, or if it loses that energy, it can, you know, kind of just slow down and become ice solid with a bunch of other molecules.
Right.
Same molecule, different amounts of heat energy.
Exactly. And whenever particles get warmer, when they gain more energy, they start moving faster. So that's really a really good way to remember that. Heat spontaneously flows from an area of high temperature to an area of what? What do you think?
Low temperature.
Low temperature, that's right. So from hot to cold. Right? Your hands were cold, you put those hand warmers in your gloves, and then the heat flowed into you to make you warmer. That's right.
Or if someone has really cold hands and they put it on you, they're just taking all the heat out of your body. So that's why they make it cold.
That's right.
Stealing the heat.
They steal your energy.
Steal your energy.
Like energy leeches.
Energy leeches, yeah.
So, and then the units for that, because heat is energy, we use joules. This is the SI unit for that. So, and then joules, because joules are always the unit for energy. All right, we're moving right along. So, if we're trying to measure heat, right? We use a thermometer. Thermometer measures temperatures, right, in degrees Celsius or degrees Kelvin. But since heat is actually energy, what are we actually measuring then with that thermometer?
It's a really good question. Well, we know, we just did gas laws, and we just talked about how heat affects things and pressure. If you increase the temperature, doesn't that make the particles bounce all around and increase the pressure?
Yeah, that's right.
So if we had one of those old school mercury thermometers, aren't we just increasing the volume, so that's why it goes up, and then when it gets colder, we decrease the pressure so it goes down?
Yeah, so those particles are moving around, right, because they have energy. So if we're measuring heat, then we're really measuring energy, and since those particles are moving, remember what type of energy that is?
Kinetic.
Kinetic energy, that's right. So a measure of average kinetic energy. Kinetic energy. Because, remember, those particles are moving, and so that heat energy makes particles move faster. So that's a way that you can remember that. Those particles are constantly moving, so that's why it's kinetic energy.
So there really is no hot or cold. All it is just the amount of movement.
Right. It's things that have more energy than others do.
Wow.
Right? And cold is the absence of heat, right? Remember that?
Cold is the absence of heat, the
Cold is
absence of
absence.
energy.
Yes. So we need to talk about different types, different ways that heat is transferred from one object to another. And there's three types of ways that happens. We would say that conduction, that's one. Okay, so we're going to write that down. Conduction. Okay, that's one type of energy transfer. And that happens between things that are touching each other. Okay, so like that hand warmer that was sitting on your hand, it was touching your hand, that's how heat was transferred into you. So conduction, energy transfer between objects that are touching.
And I really like to cook, especially pan-sear, so I love conduction because right when that food hits that metal surface and they touch, that's when all that heat starts going into the food. So.
That's right. So when food is like sitting on a pan, you know, I think that's really, really good. Can you think of any other examples of conduction?
Conduction, Well, if I go outside and it's a hot day and I touch the top of my car, sometimes it'll burn me.
Oh, yeah,
so,
there you go.
There's that.
Let's write that down as an example, right? Examples of conduction, that would be like, you know, hand warmers. And whenever you touch, like direct contact with a hot metal surface, right?
Yeah, like, funny thing is that even with a hot pan, you can put your hand right above it, and it won't burn you. But the second you make contact,
I know,
that's when
man.
it'll sear you. Yeah.
It's always between surfaces that are touching. That's conduction, right? We're gonna talk about what happens when your hand's just hovering over the surface here in a little bit.
Oh, okay.
The another example would be convection. Okay, that's another type of heat transfer, convection. Okay, and that happens inside liquids. Okay, so that's heat transfer, energy transfer.
Can it be through gases?
It can too. That's right. It's like clouds, right? And clouds are moving, and you have warm, like a heat wave moving in and pushing out a cold front or whatever. That's all convection.
I ask because they have convection ovens.
Oh.
Where when you're baking something inside of it, there's a little fan that moves that air around inside.
There you go. That's right. So an example then. Example. I can't write. I'm not typing either. So an example would be convection oven. That's good. What about when water is boiling, right?
Ooh, yeah. It always seems to be moving around.
Yeah, it is. It's like roiling, right? So if the hot water that's closest to the burner, when it gets warm, it moves up to the top, and then that colder water that is near the air surface moves back down. So yeah, it's just like constantly turning until all of it's heated up, right?
So there's like little currents in there. That's cool.
Yeah. So let's say boiling water.
Kind of similar if you're in a hot tub. Okay, all that hot water is moving all around you.
There you go.
So it keeps you nice and toasty because you always have some new hot water coming up.
That's good. That's good. All right, and then there's one more. That would be radiation.
Ooh, radiation.
Radiation. So radiation is the third type. And that happens whenever heat is traveling and it doesn't have any surfaces involved, any liquids, any gases. It's just straight energy through electromagnetic waves, right? So, and that's kind of hard to picture, but think about the sun, how it warms the earth, right? There's no air in space.
Okay.
So it's sending that heat in the form, kind of like radio waves. It's just straight energy traveling through space until it hits the atmosphere, right? So we'll say that's energy transfer through electromagnetic waves.
So that's like whenever you have you have too many lights on in your room, sometimes it can kind of heat up the room a little
yeah.
bit.
That's exactly right. I'm going to clarify here, since a lot of people might not know what electromagnetic waves are. Let's just say that how you know it's radiation is if nothing is touching and there's no liquids involved. Okay? So if you can just remember that, nothing is touching.
So is it kind of like if I go to the beach and I lay out, I feel warm because the sun's hitting me. But then if I put an umbrella over me, even though nothing's changed, nothing's touching me, nothing's moving around me any differently, I'm cooler because...
Yeah, that's right, because you're blocking that heat transfer from the sun. That's perfect.
Right.
So we'll say the sun's rays or a radiator, right? When it's really cold outside and you have like a space heater, that's just, sitting there being warm, and you're warmer just by being near it. Kind of being in the same room as it. So yeah,
don't those kind of glow a little bit?
They do sometimes if it's really hot.
They're really hot.
I was in Tennessee, and it's really cold there. It was really cold. It was like in the 20s, and every room had a space heater, and we kept those things going all the time. It was really, really cold.
So radiation doesn't necessarily mean some like nuclear power plant or anything. It's
no.
As long as it's just electromagnetic waves, nothing that's touching or a gas or liquid, and if it's still transferring energy, that would count as radiation.
Yes,
okay.
That's right. You don't have to be directly touching it, and there's no wind currents flowing and no liquids flowing. It's just happens to be there emitting those rays of heat.
Gotcha.
That's right. So those are the three types of energy transfer. And if you have any questions, make sure you ask your teacher.